Just like example 1, we are going to also graph each of these. So starting with A, y equals cos of 6x, we once again recognize our parent graph. Just like when we did transformations, we need to know what our parent graph looks like. So your parent graph, we quickly draw cos from 1 to -1. Cos starts at a maximum. And you're going to hear me using this language more and more. I didn't say it starts at 1. I'm not going to say they start at 0. I'm going to either say they start in the middle, or they start at a maximum, or they start at a minimum. Because once we start moving these graphs around all over the place, that's going to be important. Cosine graph starts at a maximum, then it goes to your center line, to the middle, back to the center line, back to a maximum. There's your parent graph. And one of the things you're going to notice that with our sine and our cosine graphs, we're not going to do exactly the same thing we did with our regular transformations, because we're going to do it in a bit of a shortcut. Now this 6, that's inside the function. Can you see that that would be a horizontal compression? That you would multiply your x values by 1/6. What is that going to do to your graph? It's like playing an accordion. You're going to squish it all the way in. How are we going to graph this quickly? Well, we're going to take our regular value of 2 pi and say, what happens if I multiplied my period, which was 2 pi, by 1/6? 2 pi, oh, that's an x. Two pi multiplied by 1/6 is equal to 2 pi over 6, or, if I wanted to reduce it, pi over 3. So my value that was at 2 pi comma 1 is now going to be at, and I'm just going to label it here, pi over 3. That point's going to be at pi over 3 comma 1. Does that make sense how I took this point, which was at 2 pi comma 1, and multiplied the x value by 1/6 to get pi over 3 comma 1? And that's exactly how we did it with transformations. Now the shortcut that we're going to use for sine and cosine graphs is, temporarily, you're not going to even label that point. You're just going to say, my new period is pi over 3. And if I take my new period, which is pi over 3, and I think about my old period, which was 2 pi, and it was divided into 4 equal sections, I'm going to take my new period, pi over 3, and divide it into 4 equal sections. A little bit of mental math. How are you going to label each of those sections? I think it's easiest to start with the one in the middle. What's half of pi over 3? Well, if I take pi over 3 and times it by half, that section would be pi over 6. I have 2 more sections to label. I think the first one is now easier, because the first one is going to be half of pi over 6. Does that make sense? So it's going to be pi over 12. And once you have the first section, and since all the sections are equal in size, you can just sort of count to get your third section. If this is 1 pi over 12, pi over 6 is 2 pi over 12s. The third one's going to be 3 pi over 12s, which you could reduce to pi over 4 and label it that way, or leave it as 3 pi over 12. And the shortcut that we're going to use for graphing this is to say, Now that I have my new period, I know that my amplitude, because there's technically a 1 out in front, which means my amplitude is 1. My amplitude is 1, so that means going from my center line up, it'll be up to +1, down to -1. Where does a cosine graph start? It starts at a maximum. Then at the next section, and we've divided our period into 4 sections for this reason, we go maximum, center line, minimum, center line. And this point that we labeled before, remember we labeled this to start off with, comes up naturally that way. Join your graphs with a nice smooth curve. And we just graphed y equals cos of 6x. For your tan graph, which is next, y equals tan of 2/3 x. Is that right? This is going to be a horizontal stretch. You're going to multiply your x values by 3/2. You're going to think about your parent graph for tan, which has asymptotes at pi/2 and 3 pi/2. And your tan graph has this basic shape, like a bunch of x cubed. To graph y equals 2/3 x, what we're going to do is we are going to apply the horizontal stretch to the asymptotes. If I took my asymptote, which is at pi/2, and I multiply it by 3/2, my asymptote's going to be at 3 pi/4. If I take my second asymptote, which is at 3 pi/2, and I multiply it by 3/2, my next asymptote is going to be at x equals 9 pi/4. And similarly, you'll have the same ones on the other side. And having those asymptotes, shape stays the same. And we've just graphed our next function. Our last example is y equals sine of x/7. Just do. That can be written like this. X divided by 7 is same as multiplying by 1/7. And with that 1/7, you can see that you're going to have a horizontal stretch by 7. And so if we look at our parent graph, which goes up to 1 and down to -1 and has 2 pi as a period divided into 4 equal sections, sine graph starts in the middle going up. There's our parent graph. What's going to happen when you stretch it by 7? What's going to happen to the one period value that happens at 2 pi? When you stretch it by 7, can you see that your new period will be 14 pi? So the period was 2 pi. When you stretch it by 7, you multiply it by 7, your new period becomes 14 pi. And so our shortcut for graphing these is once you've labeled your period, you divide it into 4 equal sections. And you label these sections. Which is the easiest one to label? I think the one right in the middle. What's it going to be? 7 pi. First one? You can write 3.5 pi, or you can write 7 over 2 pi. And if this is 3.5, and this is 2 of them, is 7.5, and another 3.5 would get you to 10.5 pi. The amplitude, right? There's still a 1 out in front. That's our amplitude. Our amplitude is 1. So it goes up to 1, down to -1. Where does a sine graph start? In the middle, going up. So at each of these sections, up to a maximum, down to the middle, down to minimum, back, and we just graphed y of 1/7 x very quickly. At the bottom of the page, you have an important formula. That your period of sine and cos, and I'll get you to write these in, can be with the following formula. It's not on your formula sheet, but your period is always 2 pi divided by whatever your b value is. That applies that horizontal stretch or compression to your period. And for tan, the period of tan starts at pi. So if you have a b value in there, your new period will be pi over b. Both of these formulas can be rearranged so that you get b by itself. So you can get b is 2 pi over your period, or b is pi over your period for tan. And questions for practice are 3, C, and D. So this afternoon, we'll start off class by giving you some time to practice some of those graphing. And to summarize what we've done so far is we found out that any value in front of either sine or cos will affect the amplitude. Any value inside the b value, I don't know if you notice a pattern, the next one we do is a c value, but the b value, that affects your period. So I remember A for amplitude, and the b value, and this is a bit of a stretch, right, but it's close, that affects your period. Okay? A value affects your amplitude, b value affects your period. So if you say it, just write it, almost sounds like you say period. So I can scroll back up a bit. Is that good? If I close this.